Alex, do we got new notes?
Oh,
So this is section 3.2, solving systems by graphing. Yesterday what we had done was graphing a system of equations on the same coordinate plane. So basically you are just graphing all of the lines on one coordinate plane. We have to go one step further and we actually want to see where the point is where those two lines cross one another. That's the point of intersection, and that is actually your solution of your system of equations. In order to understand what that means, we're actually going to start with a potential solution and two equations. And we want to see, is this a solution to that system? All that means is we're plugging this number in for x and this number in for y in both equations. For it to be a solution, it has to work in both. So for the top one, we have -3 plus 1 equals -2. -3 plus 1 is -2. So that is true. And we want to try it for the bottom equation as well. So -3 plus 5 times 1 equals 2. And we want to see if that is true. So we're going to multiply first. We've got -3 plus 5 equals 2. Is -3 plus 5 equal to 2? Sure is. Because both are true, yes, it is a solution. Questions about that first one and what it means to be a solution? So just to recap, we plugged in both of those values for x and y in both of those equations. Because it worked in both, it was a solution to that system. If we were to graph both of those, it means that those two lines would cross at the point -3, 1. Thumbs up, middle, or down. Let's try for the second one. So we're going to plug in for x and y again. So everywhere I see an x, put parentheses. I'm plugging in 5. So we have 2, parenthesis 5. And then anywhere I see a y, parenthesis 2. So plus 8, parenthesis 2. And that's equal to 11. What is 2 times 5?
10.
Good. And then 8 times 2? Is 10 plus 16 equal to 11?
Nope.
Sure is not. As soon as you get one that is not a solution, it doesn't work. Okay, so this one is not a solution. It has to be true for both. Now, in general, there are quite a few methods to be able to solve a system of linear equations. One method is graphing, finding where they intersect. That's your solution. Another method is called substitution. It means we're taking an expression and plugging it into another one. And the third way is elimination, which is where we try to line up our x's, our y's, and our numbers without any variables. And we're trying to eliminate or get rid of either the x or y. Which method we use depends on the format in which we are given our equations. So if we are given our equations and y equals mx plus b, probably going to be fairly easy to graph them. Okay, so let's go ahead and continue practicing with graphing systems. So as a recap, y equals mx plus b. M is what?
Slope.
Slope, good. B is?
Intercept.
Good, your y-intercept. Think about that like your starting point.
-7.
Right. So I'm going to use two different colors again, just so we can differentiate between the two. So for the top one, we're starting at -7. So on our graph, we're going to go down 7, put our starting point. What is our slope for this top one?
3/1.
3/1. When we don't have a fraction, we're always going to put that whole number over 1. That means we're going up 3/1. And we can also go down 3, left 1. From there, draw a straight line connecting all of those points. Are we okay with that first one?
Oh shit, take him out.
Second one,
Okay.
we're starting up 8. What is our slope for this one?
2/1, -2/1.
-2/1. So that means we're going to go down 2, right 1. And if it crosses nicely, we will see that there is a point where both of those equations hit.
Can we go up to the right one?
Yes. Yes, we can also go up to left 1. What is the point where these two intersect?
3,2.
3, 2. So our solution is 3, 2. So what we're doing, we are graphing both of those equations and finding the point where both of those lines intersect. And then we're writing that as an ordered pair for our final solution. What I'd like you to do is try number 4. If you get stuck somewhere, just look up at the screen. If you feel like you're doing pretty well, just try the whole thing and then check your answer up on the screen. I'm going to go through step by step, but without the explanations. So if you get stuck somewhere, just let me know. Obviously, those that are virtual will not be able to ask me a question as we go, but... So then...
Did you read that book? PowerPoint, stop, please. Thank you. Thanks, Nick. That's all.
Oh, nuggets. Did that
Stay
wrong.
running. Tell these JV3
Guys,
to stop.
please be quiet. You should be working through this.
I'm gonna give you a run, wait.
You do too?
No, I don't.
Gentlemen,
Cold.
I know you're not finished.
Holy fuck.
No, not cold.
Do I number 5 and number 6 on the back too?
We'll do them together.
Do we have to or no?
We're going to.
Yeah, we do. Never mind.
Jen, it's impossible.
I promise it's not.
And it's a fraction, that's your slope, right? That's
Yes.
your-
So for this one, it was 1/2. That meant it went up 1, right 2.
This is the end of my.
Guys,
Should we do this one?
if you feel comfortable enough doing it, but we're going to do them together. So this one intersects at 6, -5. How'd we do?
I went the wrong way.
I initially also went the wrong way.
Same thing.
Oh my gosh.
How do you guys
Sorry.
go the wrong way?
I just forgot the negative.
Oh, that's why. That is something fucking negative.
The virtual little kids are listening. I'm swearing, guys.
Yep, sure are. Any questions on this?
Sorry, say your honor.
Nope, no questions? Does it kind of make sense on what you're doing? For those of you that are here with me, questions, yes or no? Okay. Moving on.
Wait. Eugene. You had all that time to do it.
Hey, shut up, bro.
For the next one, somebody explain to me how to graph number 5, the top equation.
Very good.
Go down 7,
Okay,
and then your slope is 1/1.
good. So we're going to go down 7, and our slope is a positive 1/1. So now we can go up 1/1.
Up one over one takes too long to fill out the points.
It doesn't take that long. Okay, for that second part though, we have to get y alone.
You minus y on both sides.
We're going to subtract x on both sides. So when we do that, we have 4y equals negative x minus 8. And then we have to divide every single piece by 4. So we have y equals negative 1/4 x minus 2. Again, that was because we divided every single piece by 4. So where are we starting?
Oh, shoot, sorry.
Down 2.
Down 2. Please stop. Our slope is negative 1/4. That means down 1, right 4. We can also go up 1, left 4. When we do that, connecting them with a nice straight line,
Oh, I wish my lines were straight.
there's rulers.
Ruler's taking me.
Where do these two lines cross?
4 and negative 3.
4, negative 3 is the solution to this system.
Can they hear everything we say?
I don't know. I'll find out.
Jesus Christ, bro.
Number 6. X equals 5 means that every single x value is 5.
So does that mean it's horizontal?
That one is actually going to be vertical.
Oops.
So we're going on the horizontal axis to 5. And then every single value is 5. Boop, boop, boop.
Oh yeah, we got needed here. Let's go kill the
And then,
I get it.
guys, please. Where is y equal to negative 5?
on negative 5.
Down
Down.
to negative 5. And this means every y value is negative 5. So that's a horizontal line through here. Where do these two intersect?
5 and negative 5.
5, negative 5. Still okay? Okay. Now, it's not always just going to be graph this, solve this. You might have word problems too. Word problems are the way that we can actually apply what we're doing for solving systems. So for number 7, I'm going to read through the question first and then we'll kind of break it apart. A gym offers a yearly membership for $90. That's like a one-time fee, at least one time each year. As a member, you pay $4 per visit. Non-members must pay $13 per visit. Gentlemen, please stop. Which system of equations below can be used to find when the number of visits, x, is the same total cost, y, for members and non-members of the gym? So if we're trying to relate this to an equation, $90 is a once per year. So this is like your y-intercept. As soon as you sign up, this is how much you're going to pay. it's your starting amount. Whenever it says per, it means we're going to be multiplying by something. So $4 per visit means $4 times the number of visits. X in this case is the number of visits.
God damn, Kyle, shut up.
Gentlemen. Non-members, because they're not signing up, they don't have to pay an initial fee, but they do pay more each time they visit. So per visit, again, so which one do you think it is? A, B, C, or D?
B.
Is it B?
Shut up, please.
This one, we are not paying any money to start.
It's A.
So it's going to be C.
I knew it was C.
I know where it was C.
Again, that is because $13 each time you visit, but you're not paying anything to start. And then the other one is $4 per visit, but you're paying $90 up front. Okay? Does that kind of make sense?
Oh, no. Oh, no.
All right, let's see if we can write one. We're only going to write, we're not going to graph and finish solving, okay? So you want to burn 300 calories at the gym. You decide to use the stair machine, which burns 5 calories per minute, and the stationary bike, which burns 10 calories per minute. You plan on spending 40 minutes at the gym using those machines. So we want to write a system where we can use it to find the amount of time you need to spend on each machine. What are the two total things that we're given? We know when we go to the gym, we want to do this.
Wait, what you say?
What are the two things that we definitely know?
There's
Wanna-
someone looking at me.
You want to burn 300 calories.
Good. We want to burn 300 calories. And then the time, we know we want to spend 40 minutes there. Let's label X as minutes for the stair machine. And let's make Y
Oh, I'm gonna hit you. Stop.
minutes for the stationary bike.
You hear that shit?
Gentlemen, can you please stop? For calories, it says stair machine burns 5 calories per minute. Whenever we see the word per, it knows it's going to be multiplied by something. So this is going to be 5x. How much do we burn on the stationary bike?
10.
10. So that's going to be 5x plus 10y. Because again, that's per minute.
Wait, how'd you get that? Oh my fucking god.
Because it says it burns 5 calories per minute. So 5 calories times the number of minutes on that machine. And then we're adding the two amounts of calories burned on each machine to find the total calories burned from that workout. The time, we can just add X plus Y. We're spending X amount of time on the stair machine and Y amount of time on the stationary bike. This is our system of equations, and we can see which one gives us the best set of results.